Alright, we're ready to talk about the least common denominator. This is kind of the first step when we're beginning to add and subtract rational expressions. So, what is the LCD? Least common denominator. The simplest expression that's divisible by all denominators is called the least common denominator, also known as the LCD. I will call it the LCD most often because it's a lot shorter to say. So, when we're finding the LCD, I'm going to go through some examples. We want to look only at the denominators, so the bottom numbers. We don't care about the numerators. I'll give you an example from, again, we'll go back in time. If we have something like 3 over, I don't know, let's say 3 6, or no, let's do 3 what's a good one? 3/16. Let's do 3/16. And we want to find common denominator with 3/16 and let's say 5/24. Then we have to find something that 16 and 24 both go into, right? Well, 16 doesn't go into 24. That'd be a good thing to check. But I usually still like to start with a bigger number and then look for multiples of that number. So 24 doesn't work because 16 doesn't go to 24. 24 times 2, though, is 48, right? And 16 does go into 48. So your LCD would actually be 48. And so the reason we do this is to try to find a common denominator in order to add them later on or subtract them later on. But we want to find the smallest number that both of these will go into. In this case, that's 48. Oh, not 46, 48. And that would be your LCD. Okay? And if we knew that, then we could find equivalent forms of both of these using 48 as a denominator. Then we would be able to add them or subtract them. So let's look at some expressions. So we have 15 over 40a squared, 13 over 24a to the fourth. Again, the numerators we don't care about. We're just looking at the denominators. So first I'll focus on the numbers. What's something 40 and 24 will both go into? Well, I'm going to start with the bigger of those, 40, and look at the multiples of 40. Well, 24 doesn't go into 40. 40 times 2 is 80. 24, though, does not go into 80. You can try your calculator. You get a decimal when you divide. So 40 times 3 is 120. Oh, 24 does go into 120. And you can verify that. I'm going to use my little calculator just to make sure. So 120 divided by 24 is 5. So it goes in evenly, right? So we can use 120 as the number, because 24 and 40 both go into it. But there are bigger ones, like 240 would work also, but it's not the least common denominator, so we use 120 as the smallest number they'll both go into. Then when you look at the expressions, a squared and a to the fourth, well, those will both go into a to the fourth. They would also go into a to the 6th, a to the 5th, even a to the 8th, but the smallest one that a squared and a to the fourth will both go into is a to the fourth. So 120 a to the fourth, that is your LCD. So that's one type of problem you might see in this section. Let's look at the next one. Now usually, a lot of times anyway, you'll need to factor the denominators in order to find your LCD. So we have denominators here that can be factored, right? A squared minus 2a, we could factor an a out. So we get a times a minus 2. Here we have a trinomial. So in this case, let's go ahead and use our old process. So 2 times negative 10 is negative 20, right? 2 times negative 10. So negative 20. And we have we need two factors of negative 20 to add up to the 1. That's a coefficient of the middle term. So I think we could use 5 and negative 4, right? And then we're going to rewrite this thing with 4 terms. So the 2a squared plus 5a minus 4a minus 10, right? And then we factor by grouping. These first two, the only thing I can factor out is an a, I believe, so we have a times 2a plus 5. And the second two we can factor out a negative 2, and we get 2a plus 5. And so both of them have a 2a plus 5, and then we have an a minus 2, right? All right, so we've factored our denominators, and we want to find the LCD. Now this is a comma here. It's not a, we're not multiplying or anything. We're just finding the LCD. We don't need to worry about the numerators at all, right? So if you notice, both of these denominators have an a minus 2. And if that's the case, then your LCD is going to have a factor of a minus 2. But it doesn't need two of them. It only needs one. Okay. We also have a factor of a that has to be there, and a factor of 2a plus 5. So basically, when we have things that need to be factored, and when we find our LCD, we're going to include a factor of anything that shows up in either of these guys. Now, we don't have to repeat the a minus 2. We just have to include it once. But your LCD is going to be a combination of the factors that show up in either of your denominators. Making sure we don't repeat factors that show up in both places. Okay. If we did include an a minus 2 twice, it would be a common denominator, but not a least common denominator. I dropped my pen here. Oh no. Now I got it. Let's look at the next one. We're just looking at denominators. Let's factor out a w here. We get w squared minus 9. Oh wait, we can factor more, right? So we have w times w plus 3, w minus 3. All right, and then this we can factor into 2. So we can factor this guy of a w and a w. And we have a plus, what is it? We want to have two factors of negative 6 that add up to 1, so plus 3 minus 2, right? Okay, so now we're going to write all the factors that show up, making sure we don't repeat them if they show up in both places. So we have the w. We have a w plus 3, right? A w minus 3. And we have a w plus 3 over here, but we already have one of those, so we don't have to put it in again, and we have a w minus 2. So that would be your LCD. Okay, the LCD would have to include factors, any factor that shows up, as long as we don't repeat the factors that show up in both places. Now we look at this guy, right? Ooh, those look weird. Well, if you remember, if we have something like this, we could factor a negative 1 out, right? And this would become p minus 14, right? It would be negative 14 plus p, which is p minus 14. So your LCD in this case, we have a p minus 14, right? And we have this factor of negative 1. So you could write it like that. In fact, either one of those could be your LCD, but that would work. Okay, so the next thing we're asked to do is to write each rational, this is your LCD. Write each rational expression as an equivalent expression with the indicated denominator. So we're going to do a little bit of equivalent expression things. We're going to see what has been done, right? So 6c minus 5, how did we get from 6c minus 5 to 24c minus 20? Well, it looks like we've multiplied both of these by 4, right? So to get an equivalent fraction, we have to multiply both top and bottom by 4. So since we multiplied this bottom by 4, multiply the top by 4, 4 times 19 is what? So 40 plus 36, so 76, right? 76. So the question mark, we get a 76 up here. So that would be my equivalent form. So I'm going to just check, make sure. 4 times 19, 76. All right. Okay, now, Let's look down here. So what did we multiply k squared plus 3k by in order to get this guy right here, right? Well, that's a little more complicated possibly, but let's do a little factoring that might help us. So if I factor a k out of here, I get a k plus 3, right? And if I factor a k out of here, I get k squared plus 10k plus 21. Ooh, that can be factored also, right? So this is this becomes a k times 2 factors of 21 that add up to 10. Well, we would need what? 7 and 3, right? So k plus 7, k plus 3. Yeah. So now I can tell clearly. So what did I multiply k times k plus 3 by to get k times k plus 7 times k plus 3? Well, what we multiplied by was the only thing that's missing in the k plus 7, right? So we multiplied both top and bottom of this expression by k plus 7 in order to get the equivalent fraction. So 3 times k plus 7, maybe I could write it that way, 3 times k plus 7. Or if you wanted to, you could distribute the 3. You don't have to. I usually don't, but 3k plus 21 we could do. All right, and then the last one here, kind of similar here. What did I multiply this by in order to get that? Well, let's factor them both to see. Z, I like to cross my z's. Z times z minus 7. And here we could factor out a z. We would get z squared minus 5z minus 14, which we can factor more, right? Z times 2 binomials, 2 factors of negative 14 that add up to negative 5. How about negative 7 and 2, right? So z minus 7, z plus 2. Okay, so we multiply these guys together, and we need an extra factor of a z plus 2. So in order to get an equivalent fraction, we multiply both top and bottom by z plus 2. And so the question mark becomes 3 times z plus 2. Which you could distribute, but you don't have to. Usually I leave it alone unless we need to combine it with something else. So this would be a fine answer. It's like up here, this would be a fine answer. 76 is your answer. But if you like, you could distribute and get 3z plus 6. It's entirely up to you. All right, so I'm going to stop there. That's all for 6.3. We'll move on to 6.4, and we'll see how to add these things.